everybody. So to address the elephant in the room right away, yes, I am wearing a mask. I'm recording this video after school at work, so kids have been in and out in the room. So I decided to just leave a mask on. Hopefully it won't pose too many issues with the audio quality and you can hear me just fine. So in this particular lesson, I'm going to walk you through 5.4 and I'm going to break it down in a few different lessons. In this particular lesson, we're just going to be focusing on writing equations in point-slope form. So we've got a new linear equation that we're going to be talking about today. We've already covered slope-intercept form. This is going to be a new form called point-slope form. So you want something to write with and something to write on. And right off the bat, we've got an example here of a graph. The first thing I want you to do is identify the slope for this graph. And then I want you to think, is it possible to write an equation in slope-intercept form? So the form that we've already covered. Is it possible just from looking at the graph, right? Obviously, we can write that equation by finding the b value. We've learned how to do that in the past where we plug a point in, but I don't want us to do that. I want to know that if you looked at this graph, just by visually looking at it, would you know how to write your linear equation? Pause the video if you need a little more time to think about it. Okay, so hopefully you've given that a go. We should all be able to find the slope without any problem at this point. Remember that when you're looking at a graph, your slope is going to be rise over run. It's your vertical change divided by your horizontal change. And it doesn't matter which ordered pairs I start with, which lattice points I use. It's best to use 2 points closest together, which I think are just going to be this point and this point. And it's kind of doing the work out a little bit for you. If I go from this point up here down to this point, I rise 1, because I'm really falling 1. And I run 4. Positive 4 because I went to the right. So my slope is -1/4. So we should have been able to do that part without any problems. The next part is saying, is it possible to write an equation in slope-intercept form just by looking at the graph? Well, to start, I'm going to write my formula. My equation for slope-intercept form is y equals mx plus b, where m is my slope and b is my y-intercept. It's the point where it's crossing the y-axis. So I know that I can go ahead and substitute my slope here. But just looking at this graph, I don't know the exact value of b, and I don't want to just estimate it and put some arbitrary number, right? I can tell that it's definitely closer to 3 than it is to 4. It's between these two values, so it's some sort of decimal or fraction. But just looking at it, I don't know if that's a 3.1. I don't know if that's 3 and a third. You know, it's hard to tell based off of just where it's sitting without any ordered pair to describe it. So I can't explicitly write my equation just by looking at this graph. Wouldn't it be nice if there was another form where I could and wouldn't have to do all that work to calculate what the b value is? And the answer is there is a way to do it, and that's the new form that we're going to be covering today. So that's where point slope comes in. And if you've never seen it before, it's going to look a little weird. Here's the formula. So you want to make sure that you're writing this in your notes. Y minus y1 equals m parentheses x minus x1. That's point slope form. And this y1, x1 comes from an ordered pair, x1 comma y1. Okay, and then of course m is your slope. So this is a number, and this is a number. This x and this y, where my pen is hovering, those are going to be variables. Just how like when you write an equation in slope-intercept form, you have an x and a y that's still in your equation. Same idea here. We're going to have an x and a y, but then everything else is going to be a number. So all the things that I just highlighted in pink, those are going to be numbers, okay? Now, it doesn't matter which ordered pair from the line you substitute into your equation, so long as it's actually an ordered pair that it is on that line. So x1, y1 represents a specific point on that line, but it can be any point that's actually on that line. So there's pros and cons to this, right? The pro is you could use any point for your equation so long as it's a point on that line. The con is You could use any point that's on that line for your equation. So if you're comparing your answer to maybe something your peer got, and you guys use two different points, your answer is going to look different, but that doesn't mean that you're both wrong. You could both be correct, and you just use two different ordered pairs, okay? So just something to keep in mind as we do this. Also, take a look at the fact that there's minus signs in our equation. You want to keep that in mind too, because there's a very common mistake that a lot of students make when they're substituting certain values in this equation. I know it looks a little funny because in your mind you're probably thinking, we've got parentheses, don't we need to get rid of that? No, this is point slope form, and as the name implies, when you look at this equation, we have a point, x1, y1, and we have a slope, point slope form. Okay, so take a moment to copy all of these examples in your notes unless you've been provided with some printable notes already. And we're going to just write the equation for point slope form for the line that passes through the given point and has the given slope. We should always be starting by writing our equations somewhere on the page. I'm just going to write my equation up here so we can reference it. Y minus y1 equals m parentheses x minus x1. Okay, there's point slope, and that's what we need to use for all of these problems. So when I substitute, again, this first y is a variable. This y is the y value from the ordered pair. The y value is going to be the second number. So that's another thing that a lot of students get confused. They see the first number in the ordered pair and they want to substitute it for the first variable in the equation. No, that first variable is a y, so we need to go to the second number. The slope we've been given right here, that's my m, and then the x1 is the first value in the ordered pair. So I start substituting. Instead of y minus y1, it's y minus 2. Instead of equals m, it's equals -1. Open parentheses, because that's part of my formula. Instead of x minus x1, it's x minus 2. Close parentheses, and done, okay? Now you might be thinking, don't I need to distribute the -1 to get rid of the parentheses, and shouldn't I be getting the y by itself? Nope, not for this particular problem. We want to leave it in point slope form, so even though it looks a little odd, this is the final answer. The only other different way that you could write it is instead of writing -1 parentheses, you could write minus parentheses. Okay, that's the only other way that we could write this equation in point slope form. Let's take a look at number 2. We've got an x1 value of 1 and a y1 value of -3, and my m value, which is my slope, is -4. So be really careful with this one. My equation has minus signs. One of my values that I'm substituting has a minus sign. This minus sign in the equation does not take the place of the negative in front of the number. So when I rewrite this as y minus the number, it's got to be y minus and then the -3. What ends up happening is I get two double negatives. So it's really important to understand the difference here. This first minus sign is from the equation. This second minus sign comes from the fact that I'm substituting a negative number into this equation. And then I keep going. Equals -4, open parentheses, x minus my x value of 1. So the only thing that I can simplify here is that those double negatives should turn into a plus, and you should go all the way and simplify that. You never leave two double negatives like that, okay? Let's take a look at number 3. We've got an x1 value of 2 and a y1 value of 0 and an m value of 5/2. So when I write y minus y1, it's going to be y minus 0. That's my y value. And then instead of equals m, it's equals 5/2, open parentheses, x minus 2. Now, you could leave, if you're in my class, I would accept this as an answer. You could leave it like this. You may be in a class where they want you to simplify it even further. So if you're not in my class, you just want to double check with your teacher how they would want something like this written. You could leave it like this, or think about what y minus 0 is. You subtract 0 from something, it's not going to change the value. So you could write your final answer for this one as just y equals 5 halves parentheses x minus 2. Okay. Most textbooks and worksheets will write it like how I just wrote it without the minus 0. But if you're a student in my class and you wrote the minus 0, I would count that as correct as well. For number 4, we've got an x1 value of -1 and a y1 value of -1 and an m value of 2. I'm going to substitute these values for y1 and x1. And again, we start by writing y minus and then substitute the entire value of -1, including that negative. That first minus sign is part of our equation. It's not taking the place of the number that's being substituted. So we do need 2 negatives here. And then I'm going to write equals 2, open parentheses, x minus, and then my x1 value is a -1. So the only thing that I can simplify here are the 2 double negatives, which we should simplify. We never leave a negative. We always simplify them to plus signs. All right, number 5, we have an x1 value of -4 and a y1 value of 1. M value is 1. So I'm going to start by substituting. Instead of y minus y1, it's y minus 1 equals 1 parentheses x minus my x value of -4. So there's a couple things that I can do here. I definitely want to simplify this double negative into a plus, but I can also simplify this situation here with the 1 in the parentheses. This 1 is getting multiplied with this quantity. If you multiply something with 1, it doesn't change the value. So I can actually avoid writing the 1 altogether. It's understood to be there. It's kind of like when you write a 1x versus an x. These mean the same thing, right? Same idea. If I don't write the 1, it's understood to be there. And because it's not changing the value when I multiply, I don't need the parentheses either. I can just write x plus, I simplify those double negatives, x plus 4. This is oftentimes how you're going to see it written on a worksheet or in a textbook. When you see it like this, it is still in point slope form. There's just an understood slope of 1 here. And the last one, we've got an x1 value of 0 and a y1 value of 5. My slope is -8. I'm going to start by substituting the y value. So it's y minus 5 equals -8, parentheses, x minus 0. And this is similar to number 3, where we had y minus 0. That was the same thing as just y. X minus 0 is the same thing as just x. So oftentimes the way that you'll see it, written in textbooks or on worksheets, is that they won't write the minus 0, and they'll just do -8 times x, and they won't even include the parentheses here, because if you just put them side by side, that means multiplication. So again, if you're a student in my class, I'll accept this one, but this one's also correct. So you'll want to make sure to check with your teacher how they want it written. This really is the final answer down below, but I would accept the one before it as well. Okay, I'm going to pause the video. I'm going to give you guys a few to try on your own, and then when we unpause, you should see some solutions. Okay, here's what you should have gotten as your final answers. For number 1, we should match exactly. You should have y minus 1 equals 6, open parentheses, x minus 1, close parentheses. For number 2, this is how you would write it if you simplified completely. You may have also written it like this. Maybe you wrote the slope of 1 in there with the parentheses. Again, I would accept that in my class. You'll just want to check with your teacher if they would accept it written like this. But again, if you've got a slope of 1, that's not going to change anything when you multiply. So oftentimes the way that you're going to see it written is that the 1 in the parentheses won't even be written at all. Number 3, here's what you should have gotten as a final answer. Again, maybe you wrote the part that contains the x in parentheses where you're subtracting 0. I would accept this. You'll just want to check with your teacher if they'd accept it. Oftentimes, you won't see the parentheses and the minus 0 because it's not going to affect the answer. So on worksheets and in textbooks, you'll often see it written without. But understand that this just means that there's an x1 value of 0. And for number 4, similar to number 3, there's really a y minus 0. So again, you don't need to write that part in. And then similar to number 2, there was a slope of 1, so we don't need to write the 1 or the parentheses either. So hopefully these weren't too hard. Let's take a look at some next examples. So it says, writing an equation in point-slope form, make sure to copy these 2 steps so that way you know how to approach these problems. So when you go back and review your notes, you have some step-by-step guides to reference. Step 1, find the slope. In all the previous examples, I gave you the slope and a point. Step 2, plug in the slope and a point into the equation. So you might be thinking as you're looking at number 1, well, I've got 2 points. How will I know which point to use at step 2? You have the freedom to choose. You could use this first ordered pair, or you could use the second ordered pair. It really doesn't matter, so long as you're sticking to that one ordered pair and you're not mixing and matching. So for example, if I used the x1 value of 1 here, I would not then go to this ordered pair and use this y value. I would want to stick to that same ordered pair. Okay, so before we can write our equations, we should start by writing the general equation somewhere so we can reference it. You want to rewrite it over and over until you have it memorized. The equation for a line in point-slope form is y minus y1 equals m parentheses x minus x1 close parentheses. Now, step 1, I have to find the slope. I've got points that I can substitute in, but I don't have my slope, so I need to find that first. At this point, everyone should know that the formula for slope is y1 minus y2 divided by x1 minus x2, or y2 minus y1 over x2 minus x1. It really doesn't matter so long as you're being consistent and the numbers that are stacked are coming from the same ordered pair. So I'm just going to start with this first ordered pair here. Here's an x, here's a y, here's an x, here's a y. So I've got 5 minus and then a negative 4. These double negatives will make a plus, giving me a numerator of 9. On the bottom, I got to start with that same ordered pair that the 5 came from. 1 minus and then negative 1. So again, I've got double negatives here, and I add them together to get a denominator of 2. So now that I have my slope, I can now write my equation. And again, it doesn't matter which ordered pair I choose. I could use the first one. If I used the first one, my equation would read y minus 5 equals 9 halves, open parentheses, so I'm just referencing my equation up here, x minus 1. That's the x value from that ordered pair. Or I could have used the second ordered pair, and you only need to give one answer. I'm only going to show you both just to show you that either would be acceptable, but you only have to give one answer for each of these. If I used the second ordered pair, it would be y minus negative 4, because remember, we've got a minus and then a negative, so we've got a double negative, equals 9 halves x minus negative 1. So the only thing that I would simplify here is I would change these double negatives into pluses. So either of these equations would be an acceptable answer. So this is what I was talking about at the very beginning of the lesson, that there's different ways to get the correct answer for point-slope form. Let's take a look at the next one. Here's an x, here's a y, Here's an x, here's a y. I need to substitute into my formula for slope. It doesn't matter which y value I start with. I could start with the second one if I wanted to and do 2 minus negative 2. If I started with the positive 2, oh, I just made a mistake. Slow down, Miss Lorette. That's not an x or a y value, that's an x value. You guys were probably thinking, what in the world is she writing right now? That is not how we want to substitute here. So let me try that one more time. So I want to start with a y value. I'll start with the second ordered pair this time. That y value is 1, and then I subtract a negative 2. There we go. So now since I've started with this y value, I have to start with this x value, which is 2. And I subtract a 4. The double negatives up top turn into a plus. That's going to give me a sum of 3 in the numerator. And I've got a difference of negative 2 in the denominator. So my slope is negative 3/2. It doesn't reduce, so I'm going to leave it as is. And again, it doesn't matter which ordered pair I use to write my final equation. If I used the first one, here's what it would look like. Y minus my y value of negative 2 equals negative 3/2, parentheses, x minus 4. The only thing I can simplify here is that these double negatives turn into a plus. If I used the second ordered pair, so I'm going to write or, y minus 1 equals negative 3/2, open parentheses, x minus 2. And again, you do not need to write both for your final answer. You only need to provide one. I'm just showing you both so that way, depending on which way you chose to do it, you can compare your answer. All right, here are a couple for you to try. We'll pause and then unpause to reveal some solutions. Okay, so here's what you should have gotten for your answer. Again, you only needed to provide one of the linear equations. So either you got this one with plus 4 and plus 2 for number 1, or you got this one with the plus 5 and minus 1. Regardless of which ordered pair you used, you should have gotten a slope of negative 1/3. For number 2, I got a slope of 2. So regardless of which ordered pair you used to write your equation, you should have a slope of 2. And then if you use the first ordered pair, this is what your equation should look like. If you use the second ordered pair, it should look like this. The last thing that we're going to talk about is just naming the slope and ordered pair from a given equation, okay? So go ahead and pause the video if need be to copy all of these equations down. So again, it's a really good idea to write the equation for point slope form somewhere near these problems. The hardest part is naming the ordered pair. The slope is pretty much the easy part. So let's start with that. For number 1, when I look at this equation, the slope is the thing touching the parentheses. Well, if I don't see any parentheses, if they're invisible and the slope is invisible, that means there's an understood slope of 1. It's not 0, it's 1. Think back to the problems that we did on the previous pages where I gave you a slope of 1 and I had you write the equation. When that was the case, we could either write 1 parentheses and then everything inside, or because multiplying by 1 doesn't change the value, we drop the parentheses altogether. That's what's happening here. Our slope is 1, which is why they're able to not write it and not write the parentheses. The hard part is the ordered pair. Think about when we substituted ordered pairs in all of the equations beforehand. When we did that, the value of the number ended up looking like it was the opposite. So if we had an x value of 2, let's say, when we wrote this part, it would read x minus 2. It would have the opposite sign in front of it, correct? So it's the same idea. When we're pulling the x1 and y1 values out of this equation to write our ordered pair, it's going to look the opposite of what it appears in the equation. Because you have to think about what the x1 value had to be before this symbol became a plus sign, right? It was x minus and then a negative 4. So my x1 value has to be -4. That's the only way I went from, something that had minus signs in the equation to something that then simplified to a plus sign. There had to be two negatives, meaning my x1 value had to be a negative. Same thing with the y value. If this was y minus, then the y1 value had to be a -4 as well. Okay, so this is kind of what's really happening with the signs here. But if you want to think about it very quickly, just look at the sign near the number and reverse it. That's really the easiest way to do it. So if you see a plus sign, make it a negative in your ordered pair. Let's take a look at the next one, number 2. My slope, again, is the thing that's touching the parentheses. So my slope here is -1/2. And then my x value, I'm going to look at the number near the x, and remember, be careful. This says x -4, but my x1 value is really a positive. The minus sign is part of my equation, so the number that was substituted was really a positive number. And then when I look at the y value, this reads +1. It's similar to what we did over here, where it was a minus a negative, and then it became a plus. Really, this is not a positive 1 for our ordered pair. It's a -1. Number 3, our slope, again, it's the thing that's getting multiplied with either my parentheses or the x if there are no parentheses. So my slope here is 9/4. And now I think about what my x and y values are. So if you think about it, there's no parentheses here. There is a slope. My slope isn't 1, but the fact that there's no parentheses, think back to the problems that we did before. There's a 0 in here, right? If I drew these parentheses in, it really read x -0 in the parentheses. So my x value is 0, and 0 is not positive or negative, so the sign does not even matter. The y1 value, well, it reads y -5. This minus sign, again, that's part of my equation. So the y1 value is a +5, not a negative. And then number 4, we've got a slope of a -1. Remember, there's really a 1 there. My ordered pair, my x value really has to be a -2, not a plus. And my y value has to be a +5, not a negative. So again, the easiest way to think about it is just flip those signs. My slope for number 5 is -5. My x value is a +2, not a negative. My y value has to be 0. Similar to up here, it was just an x by itself, so the x value was a 0. If it's just a y by itself, the y value is a 0. Okay, so here's the last set of you try problems. Let's go ahead and pause and then unpause to reveal some answers. Okay, here are the answers that you should have gotten for all of your slopes and ordered pairs. The ones that might have been a little tricky probably were numbers 2, 3, and 4. 1 and 5 should have been pretty straightforward. For number 2, the thing that you wanted to be careful about is that the y value is going to be 0. Also, anything that had a plus sign in front, right? When you write it in your ordered pair, it's really going to be a negative. Again, if there's a minus sign, it's really a positive. You're just kind of flipping those signs. You're thinking about what it had to be when it got substituted with the minus sign in front. And then number 3, again, there's no parentheses with the x. That means the x1 value is a 0. For number 4, there's no parentheses at all. That means your slope had to be 1. So hopefully that wasn't too difficult. And as is typical, if you have any questions, just reach out to your teacher, and I will see you guys next time. Take care.